Hey guys, welcome back. We're in Garrett's classroom. Got the quotient identities.
We're going to do some learning today. Quotient identities.
We're starting off here with tangent of theta equals sine of theta over cosine of theta.
You're really going to want to memorize these.
Memorize that.
That's important. Lock it in.
Inverse it. Cotangent equals cosine of sine.
Nice. Do that. All right. We got one.
Then we're moving on to the Pythagorean identities.
Awesome.
You're definitely going to want to know these.
Yep. You got to memorize these.
Pythagorean identities. So you're starting off with a foundational Pythagorean identity with sine squared of theta plus cosine squared of theta equals 1. Good job, Garrett.
Thank you.
Then we're moving on to the next one. So this branches out from this same foundational one.
You know this, you know them all.
Yeah. So then you go to tangent squared of theta plus 1 equals, what do you think? Secant
Yes, sir.
squared of theta. Also branching out from this same foundational equation, 1 plus cotangent squared of theta equals,
What do you think?
cosecant
Yes, sir.
squared of theta. And those are your Pythagorean identities. Alright, so next one is the reciprocal identities. Starting out with sine of theta equals 1 over cosecant of theta. Moving on to cosine is cosine of theta equals 1 over secant of theta.
Awesome.
Then tangent of theta equals 1 over cotangent of theta.
Ooh.
Cosecant of theta equals 1 over sine of theta. And then secant of theta equals 1 over cosine of theta. Moving on to the last one.
Fast one.
You guessed it, 1 over tangent of theta.
Memorize them. All right. Next up. Cofunction identities. You're going to want to memorize these.
Of course.
First off, we got sine, parentheses, pi over 2 minus theta, parenthesis, equals cosine of theta. Then we got cosine, pi over 2 minus theta, parenthesis, equals sine of theta. Then, next up, we're going to move to cotangent. Got parentheses. We got, pi over 2 minus another pi. Of theta.
Whoa.
Sorry. Equals tangent of theta. I think you're getting the pattern. So, next up, we got cosecant, parentheses, pi over 2 minus theta equals secant of theta. Next up, we got tangent of pi over 2. We're going to subtract a theta from that. And guess what we're going to equal? We're going to get cotangent of theta. Then, last one, fast one. Secant, parentheses, pi over 2 minus theta equals, what do you think we got?
I think we got a cosine?
We got a cosecant. Well, that's all right, because guess what? You got to memorize them. All right, guys, last one, fast one. We got your even and odd identities.
Memorize these.
Make a line down the middle.
Line down the middle.
We got one odd column.
One odd column.
We got one even column.
One even column.
So we're going to start off with sine of negative theta equals negative sine theta. We're going to keep going. Cosecant is also going to be an odd one. Theta, parenthesis, equals negative cosecant
Oh, there it is.
of theta. Next up, we got tangent of negative theta. Guess what that's going to equal?
What is it equal?
That's going to equal negative tangent of theta. Last one, we got cotangent in this list. Cotangent of negative theta equals negative cotangent of theta. Move on over to the evens. We got cosine of negative theta, and that's going to equal cosine of theta. After that, we got secant of negative theta equals secant of theta. That's it.
All right, hey guys, so we're getting back into the first example here. So we're starting it off with this one. Cosine squared of theta minus 1 plus sine squared of theta. And so how are we going to solve this? So we got this trig identity. Cosine squared plus sine squared equals 1. So you simplify that over. Sorry guys, that's my dog. All right, so moving on. So you can simplify this right down to sine squared of theta using your previous trig function. So sine squared of theta plus sine squared of theta equals 2 sine squared of theta. So you got it down to one function.
All right, guys, now we're going to be working on verification. Example number 2. So what we're going to have here is sine squared of theta plus cosine squared of theta plus secant squared of theta. And then that's going to equal tangent squared plus 2. Sorry, theta plus 2. So what we're going to have to do here, all right, guys, we're going to have to rewrite what we're trying to verify here because you will get points taken off on your quiz. So we're going to rewrite this here real quick. All right, plus secant squared of theta. All right, so if we look at this right here, that's going to equal 1. So then what we have is 1 plus secant squared of theta plus this, which turns into tangent squared of theta plus 1. And all we got to do is verify to that. So 1 plus 1 equals 2. So we got tangent squared theta plus 2. And now it's verified. Boom.
All right, guys, so we're moving on to example 3, factoring. Starting out with sine squared of theta minus 9. And if you know anything from our other units, you know that this is a difference of squares. So you know that this is squared and this is a square. So you do the parentheses, sine of theta plus 3, which is the square of 9. And then another parenthesis, sine of theta minus 3. And there you go. Now you got it factored. All right. So last example. Example 4. So we're covering the last topic of this unit, Unit 8, which is solving. So, how are we going to solve this? Well, first of all, it is equal to 0, so we add 3. Add 3, so then you get sine, or 4 sine squared of x equals 3, divided by 4. Divided by 4, sine squared of x equals 3 over 4.
Wow.
Yeah, and then you square root this. Sine squared equals this square rooted. Sine of x equals the square root of 3 over 4. But 4 is a square root of itself, which is equal to 2, so you can simplify it like this.
Like so.
Like this. And so once you have sine of x, 3 is pi square root of 3 over 2. So, if you remember from our unit circle, sine x equals y. So, where is y equal to pi square root of 3 over 2 on our unit circle? So, if you think about it, every point of pi over 3 has y equal square root of 3 over 2, and that continues across the entire unit circle. So if you follow with me here, it then goes to 2 pi over 3, and then 4 pi over 3, and then 5 pi over 3. So your solution to this question is x equals, going from least to greatest, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that is the answer to the question. That is how you solve these equations.
That is the end of your 8.23 math video.